Hey everybody, in this video we are going to be going over the examples from the review packet for Module 7. These questions involved various finance related situations, and so we'll look through these examples and go through each of them step by step. So on number 25, this is a question that talks about simple interest. So before I get into all the details of the question, the main thing here first off, is just when you see the topic or the word simple interest, we're dealing with the simple interest formula, which is I equals P times R times T. So now looking at each of the parts of the um, formula, the P could be thought of as how much was deposited in this situation. And then R usually has to do with the interest rate. And then the T stands for time. And most of the time, we're dealing with years. And then depending on the situation, it might also be for the deposited, it might also alternative be alternatively be the amount that was borrowed for P. But in this case, we see the word deposited. $4,000 was deposited. So that's your P value in this case. And then we have a 5% simple interest rate. So there's R. And then we have 20 years. So the situation is basically you deposit $4,000 and it has a 5% interest rate, meaning if you left that $4,000 in the account, that amount would grow at a rate of 5% per year. What's the amount of money in the account after 20 years? So if you just let that $4,000 sit for 20 years, how much does it grow to become if the rate is 5%? So it's a simple formula. All we need to do is plug in our values. So we have I equals P, which was how much we deposited, was 4,000. So I'm going to multiply that times the interest rate. Now, the only extra step with the interest rate is to take the percentage and convert it to a decimal. 5% out of 100% turns into 0.05. And then we multiply it times T, or the years. And so we get I equals, when you multiply these, you get 4,000. So you might be wondering, well, how did we get the same number again when we started with 4,000 in the account? Well, I is actually the amount that the bank account grew. So we saw $4,000 of growth. So this question says, what's the amount of money in the bank account after 20 years? Well, it started with 4,000 and it grew with 4,000 more. I'm just going to say a bank account. Initially it had 4,000 plus 4,000 more. So now it's at a balance of 8,000. So number 26 is a similar example. So see if you can try 26 and compare your answer with the key. Number 26 is worked with the same formula that we used in 25. Let's look at number 27 now. Number 27 is a different kind of interest problem. It's talking about compounded monthly. So when you see compounded monthly, or just compounded in general, compounded interest, it uses a different formula, and that formula looks like this. A equals P times 1 plus R over N to the power of N times T. So breaking this formula apart just a little bit to help you understand each of the parts, P again is what it was before. It was the deposited amount, or sometimes borrowed, depending on if it's a loan or if it's a bank account that you're depositing money into. It's the P value is how much you either deposit or borrow at the beginning. R is the interest rate, so I won't write that again. N is what we call the frequency, how often is the amount, is the interest compounded. And then T is time. So now looking through the various parts of the problem, we've got 1500 was deposited. It's compounded monthly. Interest rate is 16%, and 8 years is the time period. So when we fill this formula out, it should look like A equals, so first off, P is 1500, and then we should have 1 plus R over N. So R is going to be our 16% divided by 100, so that's 0.16. N is the compounded frequency. So if it's monthly, it's a 12 since there's 12 months in a year. And then N times T, that would be 12 times 8. So now we need to go one step at a time to simplify and solve this formula. So I'm going to start with this exponent, and I'm also going to simplify this fraction right here and what's inside. So we're going to leave the 1500 the way that it is. And let's figure out, first off, what this exponent should turn into. 12 times 8. 12 times 8, which is 96. And then we've got this 0.16 over 12. 0.16 over 12. That's 1.33, and we add 1 to it. So we're going to do plus 1. So we get 2.33 repeating. So I'm going to put 2.333. It was probably a good idea to put 4 or 5 decimals in there. Now we need to first address the exponent and then multiply at the end by 1500. So in my next step, I'm going to put A equals 1500. And I'm going to do 2.33 to the power of 96. The exponent button is right there. Exponent 96. and we get this value. In our calculator, what we can do is actually multiply that times 1500. It looks like I think I may have made an error in typing it in. So let me go back a couple of steps here. Okay, I think I made a mistake earlier. So this right here is where I made the mistake. So I need to go back, I'll redo this part here. 0.16 over 12. That's 0.0133. I think that's where I made the error. And then add 1 to it. So plus 1. Okay, so this is our value that we want. 1.01. So this number should have been 1.013333. Repeating. So now let's go back and we're going to take that number to the power of 96. So we're going to go exponent 96. So we get this now. And we multiply it by 1500 times 1500. So this is the value we should end up at. And since this is dollars and cents, we should round to 2 decimals, so 5349.52. Is the amount that you will have after 8 years. So on number 28, it works similar to the formula we used in number 27. So try to do 28 and then compare it with the key and use the same formula that we used in 27. The last example here is number 29. And it addresses simple interest again. So this is again I equals PRT. So it says a $2,000 certificate, so there's your P value. Has an interest rate of 7%. And how long will it take for it to triple? So we don't know what the time is, but we do know that the amount should triple. So triple would be, if we started with 2,000, we would end up with 6,000. So it should be 6,000 equals 2,000. The interest rate is 0.07. And our time is how long it would take for it to triple, right? Because we want to go from 2,000 to 6,000. This should actually be 4,000 because over here, I'll kind of just make a note out. This should be the initial 2,000 plus 4,000 more. In order for it to triple, we needed to add 4,000 more. That's the value for I, so that's why that's a 4,000. So in our next couple of steps, we just want to solve for t. And so if we divide by 2,000 and then by 0.07, should look like this. So I'm going to first start by dividing by 2,000. So we get 2,000 again. Sorry, not 2,000. We get 2 equals 0.07 t. And then again, we are going to divide by 0.07. And we get 28.57. There's how long it would take for the amount to triple. So for number 30, see if you can approach it the same way, just to give a little bit of a clarification. For 30, just to make sure you go in the right direction, you're trying to figure out how long would it take to double, right? So double would be that 3,800 turns into double that, which is 7,600. And so in order for it to double, we would want this to look like this: 3,800 equals, and then fill in the rest of that formula there. So that way, you know that that amount is what it adds on to what it originally had. Just like that. Right, so it would be 3,800 is equal to 3,800 times 0.058 times t. See if you can determine and simplify that to figure out what the t value would be. If you have questions about these, feel free to reach out. Let me know if you have questions.